Hi, my name is Nicholas Kranz. Welcome to the Team 5 Band and Box project presentation. Our other team members are Peter Hillerman and Christopher Perry. On slides 2, 3, and 4, you will see our presentation outline. On slide 5, you will see our problem definition. We must provide 4 instruments from 3 instrument categories consisting of a string, wind, and percussion. The instruments should be capable of playing the harmonics in the range provided by the specific sheet music. The limitations provided to the team for the creation of these instruments are 10 foot of pipe, 6 foot of string, $15 per instrument, and they must all fit into a 2 foot by 2 foot by 2 foot box. The requirements and restraints that we use to come up with this definition can be seen on slide 6. On slide 7, you will see the breakdown of our band, Maroon and Gold 4. We have 1 PVC flute for the high range wind, we have 2 single string guitars for the mid range, and 1 wooden xylophone for the low range. On slide 8, you can see the drawing for the pan flute. On slide 9, you can see a breakdown of the materials I used to make the pan flute. I cut the pipe to the desired length according to the physics. Then I installed a cap on the end of each pipe and painted them chrome. Then I took 1 by 2 pine strip and created the wooden frame and stained it. Then I took the 2 pieces of wood and clamped it onto the pipes to create the pan flute. On slide 10, you can see the frequencies I used for the physics, and also the equation that I used to come up with the desired lengths. On slide 11, you can see the lengths of the tubes in correspondence to each note, and the equation I used to find the total tube length, which is just over 6 feet. On slide 12, you can see a couple of challenges that I had in creating the pan flute. The first thing was playing the notes once I had it built. Here's an example of me playing the flute. I did find that if you do not blow at the correct angle, the tones do not come out correctly. Another challenge I ran into was editing the tracks. Once I got done recording the tracks, I had to apply some effects, trim them, and then combine them to make the desired song. A couple of improvements I would have made is I would have used different caps. These caps were wider than the diameter of the pipe, and so it caused me to have to space the pipes. If I put the pipes closer together, I believe it would have been easier to play. Another change I would have made is went with a hardwood. The pine that I used did not seem to take the stain very well. On slide 14, you can see the budget. I show a list of all of the supplies that I used and the quantity they came in and the price. And then I took the quantity required to make the flute and adjusted the prices. And I came to a grand total of $8.12. On slide 15, you can see how my pan flute met the objectives. It is able to play all the notes in the high range for the song. The cost is $8.12, which is less than the required $15. It only used 6 of the 10 foot of pipe and 0 of the 6 foot of string. And with it being just under 1 foot by 1 foot by 0.17 feet thick, it'll easily fit inside of the 2 foot by 2 foot by 2 foot box and leave room for the other instruments. Now on to Peter for the 1-string guitar. Thank you.
Hi, my name is Peter Hillerman. I will be talking about the single-string guitar design. Behind me is the blueprint that I used to create the guitar. It's difficult to see, so here's the guitar itself. And next I'll be going over how the tools or the materials that we used to make it. I used 1 board, cut them 3 inches wide, make 2 of them 24 inches, and 1 of them 1 foot 10. So you can see here's the 2 foot, 1 foot 10. This is so that you can actually get this tuning pin to line up with the top part. Here's the piano tensioning that we use. So 1 piano tensioning wire, 2 piano tuning pins so that you can get the tension of the wire, and then 2 bolts so that we could create a bridging mechanism. The physics behind the guitar is here. The frequencies, we wrote those down and then used the formula below, and with 200 newtons approximately of tensioning. So the tensioning was gotten by taking the lengths that we needed within the parameters and then just making more tension so that we could get the notes. And then I placed the note that I needed, the longest one, on this board and then worked backwards from there. So tensioned this to the length that was required through MATLAB. So looking at the string lengths, the longest one, as you can see at the top, is 18 inches, or 18.5 inches approximately. So I tuned this guitar to 18.5 inches, and that was the F3, which is this note right here, just to give you a little... So you can see the notes are a little tough. They kind of vibrate a little strange, but if you get into the right harmonic, you can get it. So that leads us into the challenges. Well, the challenges was playing the notes, as you just noticed, editing the tracks inside Audacity, and then also tensioning and tuning the instrument was incredibly complex. Improvements was testing tested the bridging mechanisms, made those better, marking the lengths of the notes. That was pretty tough, and the frequencies. And also, to improve this and get more sound, you can actually put a magnetic pickup on it. Here's the budgeting analysis. We fell within $5.95. Did it meet the objectives? Yes, $5.95 for the cost. Supplies, we were no pipe, 2 foot 4 inches for the string. The size was 2 foot by 3 inches by 2 1/4 inches. And then, in conclusion to all of this that we had found out, the complexities were the design of the instruments. We used MATLAB, multiple prototypes, technical drawings to get those narrowed down. Creating the song was incredibly difficult, complex, but we used Audacity to kind of make the notes and frequencies together. And then keeping in budget, the technical drawings and multiple prototypes helped that. Thank you very much.